So the today's topic is SHA-512. SHA means Secure Hash Algorithm. So secure hash algorithm is basically do for the hashing of our transmitted messages, and the hash code will be generated. That hash code is called message digest. So what is that 512? 512 is the output bits. So according to my output bits, we have categorized secure hash algorithm into multiple parts. Like if my output is 128 bit, then we will call as SHA 128. If my output, that is the generated bit, message digest bit, is 256 bits long, then we can say we have used SHA 256. And the last one is if my output bits are 512, then SHA is 512, right? So in this lecture, we will learn about the SHA 512 because it is the recent one. So few points I want to depict before proceeding the algorithm steps about the SHA. So the first thing is about the secure hash algorithm, that is the plain text. So generally my plain text is nothing but a message. But for the processing, my plain text will be termed as a block size. So we have to divide my message into plain text block size. And the block size is restricted to 1024 bits. Okay. So if my message is, suppose if my message transmitted message is greater than 1024, suppose it is 2048. So in this case, I will divide my plain text into two blocks. The first one is 202 or 1024 and the second one is 1024, like that. So that's why I stated there plain text block size is 1024 bits. Now the second one is number of rounds. So there are total 80 rounds. And each round have different set of operations. So what are that operations? We will see. Now when one round is finished, what is the outcome? Each round produces a word. Each round produces a word. So sometimes it is called Q word, indicated as small w, and the size of this word is 64 bits. So what is word? Word is the outcome, or you can say output of each round. For processing, each round uses one constant. So this constant table is fixed and it is predetermined. So each round we use K constant. This K constant will be given to you in the hexadecimal format. Also in the SHA, we have to store the outputs, and the output of each round will become the input of the next round. So that's why in order to store the output of each round, we used buffer. So in SHA, we used 8 buffers. So buffer is used to store the intermediate result, intermediate and final result. And we have to use 8 buffers. And this buffer name is depicted as A, B, C, D, E, F, G, H. Initially, the size of this buffer is 64 bit. As I stated earlier, output of each round will become input of next round. Now suppose if my message size is greater than 1024 bits, like in this case, then we have to divide my message into two plain text block size. Each one is 1024. Now each plain text, over each plain text, we have to run 80 rounds. In this plain text block, we have to run 80 rounds. And we have to repeat the process until all of the plain text block is not finished. So each plain text block we have to perform 80 rounds until all the blocks are not finished. So first I have to repeat what I said. That is a secure hash algorithm. It creates message digest at the last. If my message digest bits is 512 long, then we will say SHA-512. So according to the output generated, my SHA is categorized. So there is a restriction that my plain text block size must be 1024. Number of rounds should be 80, and the outcome of each round will be represented as a word. In order to store that word bits, we have to use the 8 buffers. For performing some operations on each round, we have to use the K constant. So this K constant will be provided you in the terms of table and in the format of hexadecimal. And important thing is output of each round will become the input of next round. Now another step is called padding. So actually the block division of my message is not like that way. It is only for the understanding point of view. What is the actual thing? So this division is happened due to the task of by the task of padding. So suppose my plain text is 1025, and also there is a restriction that each block must be 1024, right? So I have to divide my 1025 into two blocks, 1024, and here it is 1. So here 1024 bits, yes, it is okay, acceptable. But what about that one? There is only one bit. Remaining 1023 bits are not there. So that's why we have to apply the padding over there. So padding of bits have to be performed in such a way that the whole plain text block must be the multiple of 1024. Means multiple of 1024. Whole blocks. But there is some restriction over there in the padding. So what are that restriction? Actually, what happens in the standard of SHA, suppose it is your message. Let me scroll up. this is your message, and suppose your message is of L bits, capital L bits. The restriction is that each block, if you apply the padding, then the last block will contain 128 bits reserved. If you apply the padding, then it's okay. You first divide your block into the 1024, but there must be, or you can say it may be possible that the last block will contain the padding requirement. Suppose 2048 में आपका 1024 से divide हो रहा था, right? Complete हो रहा था. So suppose it is 2050. In this case, this one and obviously 2 will be remaining over there. So in the last block, this one is the last one now. So in the last block, there is one restriction. What is that restriction? In the last block, we have to reserve 128 bits. This 128 bits is reserved for indicating the length of the message. Used to indicate length of message in 128 bits. Now in the remaining space, you have to apply the padding. What is the remaining space? Remaining space is this one, right? So same thing you have to apply over there, that this is my padding space. This is my reserved bit. It is used to indicate the length of the message, length of this message in 128 bits representation. And padding will be 1 followed by zeros. Now, we have to perform the padding in such a way that the whole block must be the multiple of 1024 bits. Okay. So suppose question is, for better understanding, if my message size is 2590 bits, then what about padding bits? Do we require padding? If we require, then how many padding bits we have to pad? So the formula is, from the diagram, we can state one formula, that is message plus padding bits plus length of the message, right? These three things would be the multiple of 1024 bits, right? If it is the case, then mod operation with 1024 should be equal to 0, right? So if we want to calculate padding bits, then what is my formula? Minus n and mod 1024. Now put the values inside the formula. What is m value? That is 2590. What is L value? L value is 128. This is reserved. And mod 1024. So the answer is minus 2718 mod 1024. So if you solve it, your answer will be 354. Now, what is the representation of the padding? Padding is 1 followed by 0. So in order to represent 354, we have to fill with 1 and followed by 353 zeros. Simple. भाई 354 बिट का पैडिंग होना है ना, तो पहली बिट को मैंने 1 लिया जैसे यहाँ पे डिपिक्ट है, and followed by how many remaining bits? 353. Total is 354. Now, one homework is to you guys, that you have to calculate what will be the minimum number of padding bits and what will be the maximum number of padding bits. ठीक है, ये आपका होमवर्क है. ये आप कैलकुलेट करना कि किसी भी मैसेज साइज के लिए मिनिमम पैडिंग कितना होना चाहिए और मैक्सिमम पैडिंग कितना होना चाहिए. Apply the same formula and do the analysis. Now my message is the multiple of 1024 bits are generated, right? And my each block size, that is M1 is 1024, M2 is 1024, M3 is 1024, and so on. Mn is 1024. Each block size must be 1024. Now what is the process? This 1024 will have to be fed over the compression function. So I'm indicating my compression function as CF. Okay. In this compression function, there are some procedure that I will elaborate after some time. So there are two inputs. The first one is message itself, message of 1024 bits, and the second one is initialization vector. So the value of initialization vector can be termed as a constant and it will be given to you. So that is initialization vector IV, and this initialization vector is fed into the H0, that is hash value of 0. So whatever the operations perform under the compression function, one output will be generated. Okay, this is one output. So this output will be fed over the one operation. This operation is called addition modulo 64. What is that? Addition modulo 64. So because there is addition means we need two inputs. So first input is the output from the compression function and the another one is the value of H0, H0. So whatever the output is generated, it will again go to the compression function. Now in this compression function, what is the output is generated after performing the addition modulo 64? It is H1. Now the other input is M2. So whatever the output is generated from there, it will be go inside the addition modulo 64. In this addition modulo 64, other input is H1. So the same process we have to repeat at the final step. So at the final step, what is the compression function input? That is Hn minus 1, right? क्योंकि 0 से start किया है ना, so it is Hn minus 1. Other input is message itself. So what the output is generated? It will be fed over the addition modulo 64, and this addition modulo 64, there is another input that is Hn minus 1. Same process I have to repeat. So because this is the last one, this is the last block. ठीक, और इस CF के अंदर मेरे 80 राउंड्स होंगे, जैसे कि मैंने ऊपर बताया कि हर प्लेन टेक्स्ट में 80 राउंड्स मेरे को सस्टेन करने. सो यू कैन टर्म एज अ राउंड फंक्शन, जिसको मैं कंप्रेशन फंक्शन बोल रही हूँ. Because this is my last block, so the output of the processing, after the processing of this last block, will be your final result. What is your final result? Your final result is HN, that is called message digest or hash code. तो थोड़ा सा कॉम्प्लेक्स है, पर एक दो बार पढ़ोगे तो आएगा समझ में. Now we have to learn about the compression function, कि इसके अंदर का प्रोसेस क्या है. Compression function, or you can say round function or round structure. So first we have to use the buffer. So we have used 8 buffer A, B, C, D, E, F, G, and H. 8 buffer we have to use. Oh. So this is my 8 buffer. So initially, the value of this buffer are nothing but my initialization vector. So initialization vector I have assigned h0. ठीक है, जो भी कांस्टेंट वैल्यू थी मेरी IV इनिशियलाइजेशन वेक्टर, उसको मैंने h0 में डाला था. So this h0 I am indicating as in the general format hi-1. In the general format, I am writing there hi-1. So whatever the hexadecimal value over there, I will be fed over this buffer. Now my message. This is my message. ठीक है, ये हर एक राउंड का मैं बता रही हूँ. सी ए फंक्शन के अंदर की कहानी है ये. ठीक, उसमें हम एक मैसेज ले रहे थे. प्रीवियस देखो, CF में मेरे दो इनपुट थे. द फर्स्ट इनपुट इज मैसेज इटसेल्फ एंड द सेकंड वन इज इनिशियलाइजेशन वेक्टर. ठीक है, तो इनिशियलाइजेशन वेक्टर मैंने बफर के फॉर्म में ले लिया एंड द अदर इनपुट इज मैसेज इटसेल्फ. Now one more thing is, here my initialization vector is of 512 bits and my message size is 1024 bits. Okay, so there should be a need of compression function. So there is a compression function. So first we need to convert my 1024 bits into the 512 bits because my output is again 512 na? And that's why we call it SHA-512. Means there is one conversion of 1024 bits. So for the conversion, there is a one algo that is called word generation. So the process of this word generation to convert 1024 into the word format means 512 bits. So this buffer will be applied over the round 0. So when my round 0 is get finished, so as I told you, each of the round will generate one word. Okay? So this word will be it will be stored into the buffer. Now the output of each round will be act as an input to another round. So this is round 1. Tick. And again word 1 over there. So 512, 512, 512 after the padding we have to feed over there. Now what is the last one? The last one round is round 79. थोड़ा सा complex लगेगा, I will repeat. Just listen properly. So round 79. In the round 79, we have to fetch the last word, that is W79. Now what is my structure says? My structure says compression function having two inputs, message itself and H0. And again, we have to perform the addition modulo with two things. The first one is output of the function and the second one is H0. And it will create H1. So output of round 79 1, 2, 3, 4, 5, 6, 7 and 8. 8 बफर्स है ना मेरे पास, मैंने 8 लाइन्स यहाँ पे ड्रॉ किए हैं. So this CF has 80 rounds, right? Now my 80 rounds are finished. And these are the same output that I am generated over there. Ye sare. And this output will be addition modulo. To perform the addition modulo. Okay. This is addition modulo. The first input is the output of the round functions, that is 80 rounds. After the 80 rounds, this one the output generated, and the other input is H0 itself. So what is my H0 value? The previous one. That one. भाई एडिशन मॉड्यूलो में तो दो इनपुट है ना, एक मेरा पहला H0 जो आ रहा है मेरे ऊपर से, और दूसरा जो मेरे राउंड फंक्शन के बाद जनरेट हो रहा है आउटपुट. ठीक है. And what is my output of that addition modulo? That is nothing but H1. So in the general term, it is Hi. So this is a completion of only one plain text block, that is M1. Whatever the output is generated, that is Hi, will be act as an input for the another function, another round structure, that is CF. Now how the word is generated from the one plain text? वही word generate कर रही हूँ ना मैं यहाँ पे, देखो ये मैसेज एम से मैं बहुत सारे वर्ड्स जनरेट कर रही हूँ, तो मेरे को 80 वर्ड्स जनरेट करने हैं. सो हाउ कैन वी जनरेट द वर्ड? So there should be one algo. So what is the process? Word generation. So this is my M1. My M1 is 1024 bits. Now from this 1024, my each word is of 64 bits. ऊपर लिखा भी था मैंने. लिखा था. हाँ. 64 bits. So means from 1024, how many bits we can directly generate? How many words we can directly generate? That is 16. Okay. So from this M1, we can directly generate W0, W1, W2, so on, and W15. Now, what is the general formula? Because from word 0 to word 15, there is no problem. But what about word 16 to word 79? So there should be some general formula, na? So what is the general formula? The general formula is WT sigma function of y12 WT minus 2 plus WT minus 7 plus sigma function 512 WT minus 50 plus WT minus 16. So you have to learn that formulas. There is no logic for there. Okay. And what about the sigma functions? So sigma function is nothing but the rotation functions. So sigma 0512 for x, there is a rotation of right by 1 bits over x, XOR function rotation of x by right with 8 bits XOR shift rotate by 7 bits of x. Then W1512, the same thing we have to perform over there. That is rotation right by 19 bits of x XOR रोटेशन राइट, ये आर का मतलब यहाँ पे राइट है, ये रोटेशन का मतलब रोटेशन है, ठीक है. सो रोटेशन राइट 61 बिट्स ऑफ एक्स XOR shift rotate by 6 bits. Means for W16, suppose if I want to generate W16, so when you put the formula, how many bits we have used? W0, W1 after applying the sigma 0512 operation, then W9 directly, then W4 after applying sigma 1 operation. So you have to perform this task for the word generation from word 16 to word 79. This is all about the compression function. ठीक है, ये compression function है जिसको हम round function भी बोलते हैं. But what about round structure? This one. इस round के अंदर हो क्या रहा है? Secure hash algorithm first is a very complex and tough to understand. So you have to learn. ठीक है, सिर्फ ऐसे सुनने से अभी काम नहीं चलेगा, खुद पढ़ना भी पड़ेगा उसके लिए. So round structure. So what happens over each round? First thing is, see the diagram. In the round structure, what is the input value? Input value is the buffer one value. Means we have to draw the buffer once again. So this is your buffer value. And what is the output of the round? Output of the round is again stored in the buffer value, है ना? ये input है और जो output है वो भी मेरा buffer में store हो रहा है. So again you have to draw buffer for the output of each round. Now, some simple things. In the output, that is the output now, and this is input, and this is one round structure. So in the output, some simple things are B will be equal to A. ठीक है? This B will be equal to A. ठीक है? Other is C will be equal to B. So C will be equal to B. So B का डेटा यहाँ पे आएगा. Now D will be equal to C. So D will be equal to C मतलब C का डेटा यहाँ पे आएगा. F will be equal to E. तो E का डेटा मेरे F में आएगा. G will be equal to F. So F का डेटा मेरा G में जाएगा. H will be equal to G. तो G का डेटा मेरा H में जाएगा. यहाँ पे मैंने उल्टा बोल दिया, F का डेटा G में जाएगा. ठीक है, F का डेटा देखो G में जा रहा है और यहाँ पे G का डेटा H में जा रहा है. ऐसे तो हमें लिखना ऐसे है और पढ़ना ऐसे है. ठीक है, A मतलब B इक्वल टू A का मतलब A का डेटा B में जा रहा है, C इक्वल टू B का मतलब B का डेटा C में जा रहा है. ऐसे ठीक है, इस पोजीशन में पढ़ना है और पोजीशन का एरो भी ऐसे ही लगाना है. सिंपल. सो दिस इज द डायरेक्ट ट्रांसमिशंस. कौन कौन से आउटपुट मेरे बच रहे हैं? द फर्स्ट वन इज ए, द सेकेंड वन इज ई. ए और ई मेरा रिमेनिंग है. सो देयर इज सेपरेट फॉर्मूला फॉर ए एंड ई. सो व्हाट इज दैट फॉर्मूला? E is D plus T1 and A is T1 plus T2. Now your question is what is T1 and T2? क्योंकि D का वैल्यू तो मेरा यहाँ पे है. What is T1 and T2? So there is separate equations for T1 and T2. Let me write the equation, then I will explain. So T1 will be calculated as the value of H plus condition function CH have to be applied over the buffer values of E, F and G plus sigma operation from 1 to 512 bits over the buffer value of E, then the word value that is generated from the message, word generation say, and KT. What is KT? KT is my constant value that I told you that we have to use the 80 constant value in the hexadecimal format, right? Now for better understanding, I will divide into 4 parts. So the first part is, let me change the color for better understanding. 4 parts. So my first part is this one value. My second part is this one value. Third part is WT, and this is my fourth part, that is adding on the constant. Okay. Now let us include in the diagram. So in the diagram for the generation of T1 value, first we have to cover the first part. So H addition modulo 64 with conditional value of conditional operation of E, G, F. Okay. So here conditional function, what is the input? E, F and G. Now it will be addition XORed with H. So whatever the output is generated, it will be condition modulo with H. So my first task is completed. What is my second one? Second one is summation operation from 1 to 512 of E. So summation operation हो गया. Whatever the output is generated from summation operation, it will be XORed with WT. So whatever the output is generated from summation function, it will be XORed with WT. So here I am writing WT, that is word generation. And also there is एडिशन ऑपरेशन ओवर दिस वैल्यू 1 and 2, ठीक है, ये मेरा 1 है, ये मेरा 2 है, 1 और 2 के इनपुट को भी मुझे एडिशन ऑपरेशन देना है, तो यहीं पे दे दिया मैंने. Then so this operation is called third one. Then what about fourth one? The fourth one is addition operation with the previous this value. ठीक है, ये जितनी भी वैल्यू आ रही है, यानी कि ये वाला जो वैल्यू है, addition operation with kt, which is 4. So what the output is generated from there, that is called t1. यही तो है ना t1, यही जनरेट किया मैंने t1. Now for generation of e is addition modulo d with t1. d with t1 हो गया, और ये मेरा जाएगा इधर, ठीक है. E will be generated successfully. Then what will be my t2? For t2 there is separate formula. t2 is saying summation operation from 0 to 512. ये सब याद करना पड़ेगा, ठीक है, ये ऑलरेडी है SHA में. तो majority ABC, majority function ABC. So we have to apply majority function over ABC, ठीक है. Whatever the output is generated, it will be, ये suppose मेरा 1 है और ये suppose मेरा 2 है, तो ये 1 मेरा complete हो गया. Then second is summation operation of A12. It will be getting addition modulo 64, क्योंकि यहाँ plus sign है ना ये, and whatever the output is generated we will call as T2, ठीक है. So ये मेरा T2 हो गया. Now we have to perform another operation. The one is from T1 and the another is from T2. Simple. Step by step समझोगे तो आसान लगेगा. What is my majority function? Let me write the majority function. So majority of ABC means we have to perform the certain operations over the values applied over the stored in the buffer ABC. So what is that? This is nothing but the logical AND operation. So AJ and BJ XORed BJ and CJ, sorry, and A XOR CJ and AJ. Then conditional CH, इसके अंदर क्या होता है? EFG, EJ and FJ XORed not EJ and GG. What is my summation values? Summation of A and summation of A. So summation of A is rotation of A, means we have to perform the rotation of value stored in the buffer of A, right rotation by 28 bits over the value stored in A. Right rotation of 34 bits over the value stored in buffer A. Right rotation of 29 bits over the value stored in buffer A. Check. Then what about my rotation operation over E value? So rotation of right by 28 bits over the value stored in buffer E. Rotation right of 34 bits over the value stored in buffer E sub XOR. Rotation operation write by 29 bits over the buffer value stored E. So this is all about the SHA. Now my one round is finished. That is all about one round structure. Suppose it is round 0. Okay. So whatever the output is generated, which is stored in the buffer A, B, C, D, E, F, G, H. यहाँ देखो A, B, C, D, E, F, G, H. It will be appended as an input for the round 1 and so on until all of the 80 rounds are not finished. So whenever the last output is generated from the 80th round, we have to perform the addition modulo with two things. What are that two things? The first one is whatever the output is generated from round 80th, and the second one is HI value, means HI minus 1 value. Then my HI will be generated. So we have to repeat this process until all of my plain text blocks are not vanished. ठीक है, ये सारे मुझे करने पड़ेंगे. And at the last block, when there is a last block is performing and there is no blocks are remaining, then it will be called as 512 hash code. Now just see the neat and clean diagram. So in this neat and clean diagram, the same thing that I have already told you, that is each block having 1024 bits. Now your initial value, that is called initialization vector, is 512 bits, and it will be act as an input for the compression function. So this is your CF compression function having two things. The first one is message itself and the second one is initialization vector. So this initialization vector is nothing but H0. So this H0 will be appended over there. Now, whatever the output is generated having 512 bits, because it is a compression of word generation over there inside the compression function. So it will create 512 bits for you. Okay? And at the last one, 512 message digest will be created. Now this is the compression function. So ये काफी neat and clean diagram है. मेरा थोड़ा सा गंदा बन गया था. So in this neat and clean diagram, you can see over there the compression function having the results of buffer value. How many buffers? 8 buffers are there. These buffers are nothing but the initial digest, that is called the initialization vector. Okay. So this initialization vector value will be appended over the round 0. Here the round 0 have two more inputs. The first one is word generation from the message itself and the k constant value. So whatever the different operation performed in each round structure, like T1, T2 calculations, and fill out all of the values of the buffer values, like the direct transmission or the calculation of T1 and T2, output will be generated and it will be again stored in the this buffer A, B, C, D, E, F, G, H. So the output of each round will be act as input for the next round. So there will be 80 rounds. So round 79 will be your last round. So whatever the output is generated from the round 79, it will be stored in the buffer, that is A, B, C, D, E, F, G, H. So from this A, B, C, D, E, F, G, H buffer, we have to perform the addition modulo. Addition modulo with two things. The first one is the previous initialization vector value, and the second one is whatever I generated from the round 79. So this is addition modulo. After the addition, the last buffer value will be created which is again the 512 bits, and that is called the final digest, final message digest or hash code. So that is all about the today's lecture. So the video recording and the PPTs will be shared to you.